Hi class, how are you today? Are you even listening? I mean, most of you are probably not even listening to this video, and you probably didn't even tell me how you were doing, and I actually really wanted to know, and now I'm getting upset, and I'm probably going to cry, and I just got off on a tangent. The learning target for today is to solve for missing side lengths using secants and tangents. For a scale, you're a 3 if you can solve for missing side lengths using secants and tangents. You're a 2 if you can solve for missing side lengths using tangents. You're a 1 if you can identify secants and tangents. And 0, you cannot identify secants and tangents. Let's get started. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So here in this picture we have a radius, CA. So that means it's perpendicular to the point of tangency, A. A is the point of tangency because it's where DE intersects with the circle at that one point. So that means there's a 90-degree angle right here. So we can use that to find a few things. So what we've learned previously is that if we know the central angle, well, we also know that CA and CB are both radii, so that means that this is an isosceles triangle, so if we know that angle ACB is 100, then we know that these two angles will add to 180 with the 100, so these two have to be 80, and then combined, and it's an isosceles, so divide by 2, these are both 40 degrees. So if I were to ask for the measure of angle BAE, that would just be 90 minus 40, which is 50 degrees. And you can use things like that to find angle measures. I'm not going to focus too much on that today, but that is an important point about tangents. Alright, now let's talk about tangent lengths and secant lengths. So if you have two tangents, like in this first problem, the two tangents at the same intersecting point are always going to be congruent. So in this case, AB is going to be equal to BC. That is always true. In the second one, if you have a tangent and a secant, so tangent intersects at one point, secant intersects at 2 points. And again, they have to both be coming from the same point. So if you take the length of the tangent and square it, or multiply it by itself, that's going to be equal to the length of the first part of the secant multiplied by the entire length of the secant from the point to the edge of the circle. And then the third one, 2 secants. So it's the first part of the secant multiplied the whole secant up until the edge of the circle is equal to the first part of the secant on the other side multiplied by that entire secant up until the edge of the circle. Okay? So for number 1, we've got 19 equals 2x minus 3. Add 3 to both sides. And we get 22 equals 2x. Divide both sides by 2. And that will give us x equals 11. For this next one, one tangent and one secant, we've got 14 times 14 is equal to 7 times 7 plus 4x. It's the entire length. So it's the first part times the entire length. So 14 times 14 is 196, is equal to 49 plus 28x. So subtract 49 from both sides. And that will give us 147 is equal to 28x. Divide both sides by 28. And that will give us 5.25 is equal to x. And in the last one, ji times jh. So 4 times 25, the entire length, remember, is equal to jk, which is x, times the entire length, x plus 3x, which is 4x. 4 times 25 is 100, is equal to x times 4x is 4x squared. Divide both sides by 4. X squared is equal to 25. Take the square root of both sides, and that will give us x equals 5. And its length, so we can only have the positive version. Now time for the sponge. So we have 3 problems, and for each of them, I want you to solve for x. So same thing we just did, I just changed the numbers around. So for each one, solve for x. That's it for the lesson. Once again, please make sure to take notes on the entire lesson, go back to the beginning and rank yourself. Take a picture of everything, submit it all to Google Classroom, and have a good night.